We are going to talk about the Information Assistant Industry Accelerator. We'll get into what it means to be an accelerator, industry solution accelerators that we have here at Microsoft. But first, my name is Nehemiah Kuhns. I am an Azure Data and AI specialist with the joint team, so I cover about half of the fourth estate. Everything from DISA and DARPA down to DTIC, DFAS, DCAA. So we run the gamut on the joint team of the different customers we support. Also running in the back was my manager, Brandon Rohr, here to help assist with any questions also throughout the presentation. So as we get into the actual presentation, we've got a few slides that will talk a little bit more about Information Assistant itself, what it is, how you get access to it, things you can do with it, and then we'll get into a live demonstration where the demo gods will favor us today and things will work with this demonstration. So we'll see how that goes. Brandon, if you want to go on. Okay, so first off, what is an industry accelerator? What is a solution accelerator? So these are Microsoft created, Microsoft developed open source software solutions that are meant to answer very specific industry questions. They're expected to be 70 to 85% solutions for these types of problems. So in this case, we have again, no charge code that's developed, sits on GitHub. You're able to go in, modify the code as necessary, pull it down, deploy it into your own space. Infrastructure is code. Everything is built into it. So it can be as much of a push button deployment for the initial testing phase so that you can get onto it and see what the art of the possible is with this code base. I know a few people in here mentioned they've already done some deployments in the back previously. So we're going to talk about the newest version that was released just, I believe, a week and a half ago. So version 1.1 has quite a few updates. And so we'll get in. If you've seen it before, this will be something slightly different likely. So on to the next one, please. Okay, so for Information Assistant specifically, like I mentioned, we've got the infrastructure as code. Sitting in there is one of the resources. You've got a deployment kit that includes some code for a container where all of your requirements are built into that container for the deployment. We have a calculator where you can estimate kind of a t-shirt size, what it might cost you to run the accelerator, because the accelerator and the code itself is free, but where the cost comes in is when you actually start running this, because all this is going to deploy solutions into Azure. So it'll be leveraging a lot of our Azure PaaS offerings to enable this accelerator here. You also get documentation, everything from architectural diagrams to configurations, and what it might look like to do some of this work in different types of clouds. So we've done cloud deployments in both commercial and Gov, and the demo we'll be doing today will be actually sitting on my own Gov subscription. So everything you see that we're doing is available in Azure Gov right now. Next slide. All right, so I mentioned industry accelerators are meant to answer specific problems and help become a springboard for solutions to those problems. So you've heard this over and over today, yesterday, in all the conversations that you're hearing in the news. These are dated models. The GPT models are snapshotted at a specific time, and they only know data up until the end of their training set. So you've got your dated models. It's trained on the publicly available information, not your own. So this is where we bring in the Retrieval-Augmented Generation and other capabilities to help bring more context to the responses to make it more relevant for you and your users. Fabrication, so we've got hallucinations are a big problem. If I were to go in and tell GPT to tell me about Nehemiah Kuhns and the work he's done at Google, it will try to give me some sort of response about what I've done at Google, even though I've never worked there. So we try to make sure that the responses we're getting back have as few hallucinations as possible, while also giving you some clarity and citations in the back end. So we pull out any information we're pulling out from your data. We're giving you those citations so you can double check and sanity check that everything's working there. Go ahead with the next one. So overall, Information Assistant is going to assist you in all of those. We've basically talked about most of these, but there are a couple things that we can do with personas. Bless you. The GPT models, we want to let them know who they are and who you are so that they can have more context in the way it should work the responses. So those are built in. We've got a bunch of little tweaks we can make to the interface as we get into asking questions of the model that we'll get into the demonstration portion. Next slide. talks about some of the more recent changes coming with version 1.1. So one of these is the ability to do a secure deployment. So as we start looking toward IL4 and IL5 workloads, you need to have things behind these private endpoints, inside VNets, behind firewalls, customer managed keys for encryption of data at rest as you get into IL5. So these are all things that are being baked into the solution as we move forward. There's a lever to switch on for the secure deployment. Coming soon in the GovCloud, which it gets a little tricky with this next part, but SharePoint, the ability to connect to your SharePoint databases and say, I want to ask questions about this SharePoint directory, and then we can start pulling documents in, pulling information in, enabling the GPT model to have that data as a context source also. A lot of times, you want to ask questions against your data, but you also want to have that traditional chat GPT type interface with the large language models. It's hard to do that when it's trying to answer questions based off your own data. So we have the ability to chat directly with the generative or ungrounded portion there is we take away the grounding part and just say, okay, just chat with a large language model. And that's where you can have some of those more GPT or chat GPT standard conversations. We also have the ability to mix both grounding with your work information, so all your own documents, as well as adding in a plugin to Bing Search. So on the commercial side, we can connect directly to Bing Search and ask questions that way. Now, you're not sending your data out to Bing Search. Rather, you're complementing your grounded responses with responses from a search query to Bing also. So this is something if you're thinking with people that are more on the research side, that have questions that they want to be able to ask against publicly available information across the web that's more recent than whatever the snapshot date is for that GPT model. We have an option for that. We've got the safe search filters in there. Two new additions to V1.1 is a math assistant and a structured data question answer type assistant. So these are using LangChain with agents in the back end to build out that thought process and help give you a little more capability than just the GPT model by itself. So I used to say that I wouldn't trust the GPT models to balance my checkbook. We'll run a couple examples through the math assistant that shows it has a thought process that's able to call Python workbooks and other things to actually start answering math type questions. So on to the next one. Okay, so again, a little deeper look into the chat experiences that we have. You've got your grounded, and we'll talk architecture about what exactly is going on here in just a moment, but your work, which is purely grounded, work plus web, which will reach out to Bing also, and then the ungrounded, which is just that traditional GPT type interface. All right, so the grounding process. There's a few ways to do grounding, and traditionally when people think of AI models or traditional machine learning models, they think of fine-tuning the models or changing the weights or doing something to change the model itself. Well, there's a reason that Microsoft has spent over $10 billion assisting OpenAI with doing exactly this. It's expensive. It's very difficult. It's a non-trivial problem to rework these large language models. So what we have is the ability to, instead of changing the model itself, it's pretty good as it is. Let's just give it the context of what you're talking about. So the way we do that is you've seen multiple architectures. I try and kind of kept this at a 30,000 foot view. You have a data source with your data source information pulled into embeddings or some other keyword search type capability. We do a bit of a hybrid search in this case. And you have some gateway application that when you ask a question, it takes that question, searches the database, pulls back relevant information, sends that as context with your prompt to the model so that you're getting the model's ability to respond with natural language processing type interactions with your own context. And so we'll dive in a little bit more here. So for example, if you were to ask the GPT model just out of the box to define safety, observer, and chase, you're going to get something very generic when it that relates to aircraft, and in case something's going wrong, you want a person needs to be in a certain place to assist the pilot of the plane that is having the problem. In this case, this specific question was from one of our former F-16 pilots in Microsoft that had an issue, and when he was teaching another F-16 pilot. And so what they needed to understand was specifically out of that Air Force manual, what the definition of that was so that they could get into the right placement for that type of aircraft and help assist him to get to the ground. So it's that specific context of I'm in the Air Force, I need to understand the Air Force definition versus just a generic definition of what it might be that we can't guarantee GPT actually knows and isn't just making up based on the context of the terms. Next slide. Okay, so now we're going to get into some more of the specifics for Information Assistant itself and how it is actually working on the backside. So go to the next slide, please. So this is very busy, very in the weeds, but generally, if we're looking at this, the orange circles are the data flows and the ingestion of the documents into the system. The green are the data flows for the prompts and what happens when you actually are interacting with the system. So we can see with the SharePoint connector and through the user interface or just directly into blob storage, you dump documents in. That triggers an Azure function to pull those documents, and depending on the type of file that you're pulling in, it will either send it to Document Intelligence, which many of you heard earlier, helps crack the documents, pull out some of the terms, runs OCR potentially against some of the images, or it'll go through another document, an open source document, unstructured IO way to pull out the information from the document. Then if you have a 500-page document, these models don't have large enough context windows for that. You can't send 400,000 tokens across to GPT and expect it to get you back anything. So what we do is we then chunk those documents into smaller pieces so that we can give context from across an entire document. And we do that along with translating. We have our AI vision capabilities in there to give context about images themselves. And then once we do that, we embed those models. So we get a numerical version of all of that text that then helps us relate the similarity of different pieces of text. So we take those embeddings, we take the chunks of the documents, put them into Azure AI Search, formerly Cognitive Search, which many of you heard about again today and yesterday. And then we have our corpus of data against which we can ask questions. Now, when we ask a prompt or send a prompt to the system through the user interface, that prompt goes through a few stages before we actually get the response back. So first, we take the prompt and we tell GPT to give us a better way, or give us the keywords that we need to search against the database to pull back context. So we're not sending the entire prompt, we're just getting a better query term. So we get that back. We either go directly to AI search or in tandem go out to Bing search if you're on the commercial side right now to ask the question. We pull back a certain number of documents. So you can set how many documents you want to pull back or chunks of documents you want to pull back. And then we send all of that information along with the prompt to the model and get a response back. We ask it to give us citations. We ask it to tell us that it doesn't know if it can't find the information in the query. So we're able to take care of a lot of those issues we see with ChatGPT just through some prompt engineering. So next slide, please. Yep, go ahead.
Is the vector database Azure AI Search that represented there, or a bigger part?
So Azure AI Search is where we are storing the vectors. So we're using it both as a keyword search index as well as the vector database. Inside the index, you have your chunk of data. You also have keywords, and then you also have the vector itself. So we're leveraging AI Search as the entire corpus, including the embeddings. Yes, sir. Yes, go ahead.
So the SharePoint connector, is that part of like a premium connector, or is it included with the Azure AI?
Do you have an answer for that, Brandon?
The SharePoint connection is actually made through Logic Apps. And I believe, I don't think it's a premium connector, but basically Logic Apps, you'll log in with SharePoint. And then that's the integration. We'll go through and iterate through the files and pull them in. They go through the enrichment pipeline that will eventually land in the search. So we're not querying SharePoint directly. We're hooking to SharePoint to pull in the files, to do the same enrichments, to eventually land into vector search, that we can then ask questions.
And Logic Apps is through Microsoft, or is it?
Logic Apps is a low-code, no-code service that is available in Azure Government Commercial. It hasn't service.
Okay, thank you.
Other questions? I like to talk and I talk fast. So just throw a hand up or throw something at me.
Would you say it's a requirement if you use Azure OpenAI to get this industry accelerator? If you didn't have it, you'd be limited, or you'd have to create it all on your own, take a lot more time.
Correct. Absolutely. Yes.
Think of it as like a starting point, right? So if you,
It's a good springboard.
right, it's never going to be a direct fit, but you can take pieces of it. Hold your own, or if you're starting somewhere, right, take the back end and incorporate it in what you have.
Absolutely. Yeah, we have some people that don't even leverage the front end portion of this. They build their own. They use the enrichment portion of it, and then just use the index itself to connect into their own applications that they have. Yeah.
So they just cherry pick with it.
Exactly. Yep. Absolutely. Yes.
So another quick question with the different modes. There was the work
Mhm.
and the web
Right.
through Bing integration. I was in a different breakout room and we're talking about that, and might have been some confusion with the GCC environment. But if that is on, and let's just say you're through the AI, you're searching for PII or something like that, that doesn't go out to Bing at all.
Correct. Yeah. This
It's built in with the policies and everything already in, because before it was like you kind of have to build it out, configure it before,
Right. So what goes out to Bing is actually your prompt. So if you expect to have prompts that are going to have issues like PII or other things in that needs to be something that you build in and you anticipate ahead of time.
The Bing API that we're using today is not available in Azure. So if you chose to use that and you were releasing in a GUI, you would need to make sure your users knew that.
Thank you. Other questions? All right. So we're getting pretty close to the demo here. Just a couple more slides. So here's the model availability in Azure Gov as of last week. So right now we've got GPT-4 Turbo, specifically the 1106 preview version, available in 2 of the Gov regions. 3.5 Turbo just came online a couple weeks ago, available in Virginia, and then we have our embedding model available in both Virginia and Arizona. So we don't have specific timelines on when the other models are coming in, but if you see a new model coming in commercial, expect there to be a lapse before it hits Azure Gov. Just like before we even get it in commercial, there's a lapse between OpenAI announcing it and us specifically having it right away. So this is the most current that I had availability for Azure Gov. We did announce last week that Azure OpenAI is available in TS also, so we're working air-gapped clouds also. I don't have availability or any timelines on any of that, but it is something that if you have those types of workloads, you can start talking with your Microsoft representatives on that. Okay, and then this is something we hear a lot about, especially with this being the security summit, or mixed in with the security summit here, is what about assurances of our data? So you've heard this over and over. I do want to kind of poke in on a couple of these. The OpenAI service, you're not hitting ChatGPT, you're not hitting commercially available OpenAI. It's a service with a model deployed into your subscription. You've got your own endpoint that you can leverage via RBAC or via a key. The models themselves are entirely stateless. They're fire and forget. Nothing sits beside the model. The model doesn't retain anything. The model doesn't learn on it. All the models are stateless. They're snapshotted. They don't learn anything beyond what the context you're giving it, and then they forget it as soon as they respond. Your data is your data. So the responsible AI portions, we have a lot of things in place, particularly in the commercial space. If you're leveraging this in Azure Gov, we have turned off the human review for abuse monitoring and the content filtering that we have on the commercial side, with the idea and understanding that if you are in Azure Gov, you likely have a sensitive workload that you're running. And so the onus is then on the application owner to put those responsible AI principles in between the users and the model itself. So that's something to be aware of, that those are assurances that you need to build in from your own security perspective on what you expect to come through those systems. Again, nothing is available to anybody else, not Microsoft, not other users of the OpenAI service. The communication stays entirely within your subscription, especially if you're using the private VLANs and everything. We do have links here. You can search these. These are all completely available on Microsoft Learn. Most of these are Microsoft Learn, along with the announcement about air gap clouds and other things coming down the pipe. Okay, and now we're on to the demonstration. So any questions before we hop into the website here?
When you say the filter turned off for government, does that mean I can now ask ChatGPT to like give me like malicious Windows command line for whatever, and it'll do it?
GPT itself has the understanding of not wanting to put out malicious things itself. So whether it would put it out or not, I can't answer that. I haven't tried it. One, I don't think I have the filters turned off. And two, I don't want to go there myself. So
Same safeguards are there. It's just not going to flag it human review.
Gotcha.
right, yeah. So on the commercial side, that's what happens. That's right. So on the commercial side, it flags it, it would save that off, and then literally a Microsoft employee could go in and review it and say, okay, yes, we need to flag this, we need to restrict this user's ability to access this, so forth. But again, yeah, on the in Azure Gov, the human review portion's turned off.
Thank you.
Good save there, Brandon. Okay.
To answer your question, though, once you configure alerts to say, hey, if it violates it, send an alert to the security team so they can look at the user.
You create your own workflow to track what prompts are being asked and how to triage. Should we flag this for my own internal review?
Right.
Then have somebody review it. Yeah. The onus is off Microsoft because you don't want Microsoft people, right, whether cleared or not, to look at it, decide that, right? Your own organization should flag and decide that for yourselves.
Yeah, great question. Good clarification.
Audit logs.
Pardon?
Audit logs.
Yes.
Exactly.
Right.
Okay, so before we jump into actually chatting with the data, we'll get through some of the back-end stuff here. So if we go up to the manage content up at the top, I'm going to show what it looks like to upload a document, or what the website looks like. So here you can see the supported file types. All the text file types that you could expect are in here: HTML, emails, messages, Excel, PDFs, also CSVs and JSONs here. So you can upload, you can choose a folder. So this is one way that you can set up filters. And then on top of the folder capability, you can also add tags if you want to further refine the filters and the search as you're going through. Those get saved off beside the document in the index and act as a way to filter through as you're going through the search. Click and drop, or click and add or drag and drop there also. New to V11 is inside the upload status. If we do a refresh on the last 30 days, we have a lot more information that's available to us now. So you can see not just the name of the document, you can see the type of document, you can see the specific folder it's loaded to, as well as its tags. Status details, if you have an error, it'll be more robust in telling you exactly what that error was in uploading. You can select the documents, resubmit them if they do error out for whatever reason. I had an issue.
1.0 where like wasn't very detailed what was problem.
Right.
Yeah.
Yeah, and so I had an issue the other day with a 1.0 deployment that I couldn't figure out. Restarted the embeddings process in the back end, resubmitted, and it ran just right through. So it's great to be able to do it from that perspective, but even bigger is that you can delete from here now. You can select a file, delete it. There's an Azure function that runs in the background every 10 minutes. It checks for recently deleted documents and then wipes them from the rest of the system. Wipes them from the AI search index and wipes the information from anything that might have been found in Cosmos or the two blob stores where the documents actually are. So
Then it has update vector store too.
yes, it deletes the vector store because the way the embedding sits within the AI search in the index, it's an item in that index, and when you delete it out of there, it deletes all the contents from that portion. Yep. Okay, so now you can go off to the side, back on the chat side, and you can see all the information about the build and version, the specific instance name, the model you're using, the version you're using. And then if we go into adjustments, we can, again, tell it how many chunks of documents you want to pull back. You want to keep this relatively small because, again, the models have only a certain context size. You've got a tokens per minute limit that you need to be considerate of. So that's adjustable there. You can suggest the follow-up questions. Importantly, you can give it the user personas. You can tell it what kind of user you are and what kind of user it is. So if you're working in finance, you want to tell it that it's a finance assistant or it's a finance analyst. Give it that context. One of my favorites to do is tell it that it's a native Texan that speaks in Texan dialect far too often and uses the term y'all every chance it gets. The responses are fantastic, by the way. So that's it does work. It gives it that extra context. So I've heard a lot of talk about temperature. Rather than specifically calling it temperature here and giving you a slider between 0 and 1, we give you the ability to choose length and conversation type. So if you are asking a very directed and specific question, you want it to be a concise and precise response. If you're asking it to generate a document with some of the context, then you want it to be a little more creative and robust with its response. So that's the sliders that we have there from that perspective. Here you can see the folder selection. So for this first example, we'll select just the Air Force folder, and then we're going to add in the F-16 tag. So not only are we saying, hey, I'm in the Air Force, but most importantly, I'm most concerned about documents related to F-16s. And so we can go in and ask a question. So what is a circling procedure protected areas? What that ends up giving you is, so as it's generating the response, I'll talk again what's happening. We ask the question to the model. The model gives us back a query to search the database with. We search the database, pull back the chunks, give those chunks and the prompt back to the model, who then creates a response and sends it back to us. Now, we're not seeing anything popping up like you do in ChatGPT or in Bing Copilot, because rather than streaming that to the front end, we opted for just the batch deployment where it'll just dump everything out as soon as it gets the response back. And I said the demo gods are going to be nice to us today, but we'll see how it goes. Yeah, we need to wake it up a little bit. So what we're going to see is similar to what we saw from a couple demonstrations ago, where you have your response, you have your citations, inline citations, as well as clickable citations at the bottom. And what you can do from there is not only see, okay, here we go. So we get information, we get tables output. We can see that here's a citation, very specific information. We see the citations and different citations. And we can see here, if we click on the one 288, so that 288 is chunk number 288 out of this document, starting at 0. So here we see the number of tokens. We can see what page this came from the actual document, the AF manual itself. We can see the content that was pulled. But most importantly, if you click on the document part of there, we're able to actually go in and see, okay, this is if you look in here, it likely references a figure. And here you can actually go in and see the figure and get the visual of what exactly it's talking about. So you can verify by going through the document itself, the actual manual, that the context you're getting back is correct. And you'll notice that at the top left, those altitudes and the categories line up to the table at the bottom right. So it was able to pull the context out of that table itself also. Okay, so any questions with the first example? We're going to jump in. We've got quite a few examples here that we want to look at. Okay, so we'll jump in and go out of the Air Force. We'll turn off the tag and go to the public regulations. So a few weeks ago, I live out in the middle of nowhere, East Texas, and the water started smelling very chlorinated, like got out of the shower and you felt like you just got out of the pool. So I did a search, maximum residual disinfectant levels and goals, to understand what actually you can have in the water. This is going to pull up section 590, and it gives us a little bit of information, but it's not super human readable. We see chlorine, chloramines, as well as chlorine dioxide, but not a lot there. So we ask it to put the output into a table format. So now we can get a table. But if you notice, we're seeing Cl2 here for both of these. Well, that's great for chlorine. Chloramines, not so much for chlorine dioxide. And these numbers are the same. So then we ask it to get rid of the goals. Those are the same information. And let's move the chemical compound names back to the actual chemicals so we can understand exactly what we're looking at from that perspective. And so we'll get a response back that should drop off that first column in this case and move the Cl2 and the ClO2 down to the respective rows. And it decided it didn't want to do that. Oh, good enough. We get our chemical compound. Here's its own. So it's a great way to interact with it. So this is showing a little bit more than just that we're able to talk about or ask about the documents, we're able to go back and forth with the model and ask it to refine things. That's showing us a couple things. One, the model can understand the context and the request in a human readable format in the human language and output something that we would expect to see. And two, we're keeping history. I said these models are entirely stateless, so they're fire and forget. So if I didn't have history enabled via basically in-memory storage right now with this, if I asked it what the state of or what the capital of Texas was, it would say Austin, and I would say, is that bigger or smaller than New York City? It would say it didn't know what I was talking about because New York City is a city, but it doesn't have anything to reference. So here I'm telling it, hey, in your last response, change your response and do this. So we've actually built in this history via in-memory capability. So that's something that you can continue to have the conversation, but as soon as we hit clear chat at the bottom left, if I were to ask any of these questions, it would have no idea what I'm talking about because I'm wiping the history and showing that that model itself is stateless and it doesn't remember what I was talking about. Unless you tell it something, it doesn't know it from your history. Okay, and we've got one more example here. So we're going to do a quick example of chatting with it ungrounded. So we're going to ask about the recent trip to Israel that Anthony Blinken took. And because this model is snapshotted back in 2023, it has no idea that he went to Israel a few weeks ago. So we get general information, you know, typically you would expect these people to see and go do these things in Israel. But if we turn on the grounding portion of this and change from the public regulations to public affairs, so another common use case that we hear from customers is, I need to put together a sit rep for a general or somebody. I need to be able to understand what's going on. Here's an example. Tell me about Anthony Blinken's trip to Israel. And we'll get a response back that specifically references his trip 2 weeks ago. He visited Rafah. He went and talked to Netanyahu about topic A, B, and C. And then it'll give us some citations specific to the document that I uploaded. And the document itself is what I want to focus on here. So defense minister, he went to Rafah, we can see, talked about the war in Gaza, which again, the GPT model itself did not have any context because I think the training for that was only up till, it might have had the context, but it wouldn't have known anything about current events with the war itself. But most importantly, if we click on any of these citations, the content there is entirely in Arabic. So if you click on the document, that's the document that I uploaded. I went into Al Jazeera, pulled off a document or pulled off a news article about the trip, dumped it into a Word document and put it through the pipeline with no other alterations to the document. So that pipeline translated this document. So if you go up to supporting content there at the top, you can see the translated portion that we're pulling back out of the system. So we were able to dump in non-native language documents, translate them into our chosen language of English, and then ask questions about it. So from a public affairs perspective, you don't have to have a translator sitting and reading through all these documents and trying to manually output summaries of these documents. This is something we can do with our system in the backend and then leverage OpenAI on top of that. So the translation itself is not happening with OpenAI. We're actually using, which it can do these translations. The translation is happening with our natural language processing capabilities that are approved and are available at IL5. So these are things that you can already start doing even without Azure OpenAI sitting on top of it. So little nod to the things that are available right now and what we can do once we get Azure OpenAI available at IL5 on top of it. Okay, so we have a little bit of time. Questions before we go into some of the preview or alternate capabilities here? Yes, sir.
What the release cadence going to be? Like you have version 1, is it going to be every quarter, you think, or any ideas?
Have they given you an update on what they expect?
No, I think quarter is probably a good basis. There's a decent amount of backlog and features because it's an open source project on GitHub. You can go out and and view the backlog and also submit bugs and things. Yep.
Okay.
Yeah, I actually myself put in the deletion function that I mentioned. I wrote the code and just uploaded it to GitHub for the team too. So
Okay.
Yep. Question, yes.
So the translations that you just showed us a while ago, how accurate are they?
I don't know if I don't have specific numbers off the top of my head, but we have John Dodson, who's not in here now, who is a computational linguist. And the natural language processing capabilities available through Azure are literally top of the line. I don't have specific numbers on any of the tests that we might run against those, but summarization, both extractive and abstractive, translation, named entity recognition, all of those are top of the line capabilities available through Azure.
We can pull John back in here at the end and
Yep.
make him give you numbers.
Okay, so speaking of numbers, so I have a PhD in mathematics. I saw the math assistant pop up and I got excited because now I can use this to balance my checkbook. So we have a question, and most of you have seen a question like this before. Train leaves Chicago, traveling 30 miles an hour east. And another one leaves Chicago, traveling 40 miles per hour south. How far apart are they within an hour? Well, if you do enough construction, 3, 4, 5 triangles, it's going to be 50. Okay, cool. But how is the model going to get there? What is it actually going to do? And is it going to give me the right answer? So if you click show me the answer, you'll get a response back that'll say the trains are 50 miles apart after 1 hour. That should be the expected response. In a moment after that pops up, we can click on the show me how to solve it. And this is where we're using those LangChain agents in the backend to do some of that extra work. Like, hey, model, here are some tools available to you. Here's the question. Call the tools you want to do to answer these questions. So we saw it said 50 miles an hour. And now we can see it actually called a specific tool, the calculator. There's the input, square root of 30 squared plus 40 squared. And then it actually writes it out step by step. Here's how we would do it. This is a right triangle. These things are traveling perpendicular to each other. We're going to look at the length of the hypotenuse. To do that, you look at Pythagorean's theorem. A squared plus b squared is c squared, where c is the hypotenuse. So there, we get a nice output there. So this is an example of the types of things that can be done beyond just a simple query. I've seen examples with agents where you give it a binary file, tell the model, hey, here's some tools to crack it. Here's some tools to decipher what's going on. Why don't you take a look at this file, pull it out of its compiled state, decompile the file, rename everything in there so it's human readable, and then tell me if there's any potentially malicious content in there inside the code. And that's all using similar agent type capabilities. So this is a pretty direct example of it, but there's a lot that can be done with the OpenAI models outside of just asking questions and trying to make the model mad at you, which is exactly the first thing that most of my customers do. Okay, so now if we go over to the tabular assistant, so a lot of people want to be able to upload structured data and ask questions about it. So we have an example of a table here of different parts from a vehicle. You can ask questions against it. So we have out of the box questions here. We can ask just how many rows are there. It'll go through and it will generate a response. And if you just ask or tell it to generate the answer, we've got 239 rows. And we can see that it's talking about a data frame. So if you're familiar with Python or any of those tools, we can see exactly what's going on. We have the data frame loaded. Now, summing up the number of rows is all good, but what if we want to ask something specific about an entry in there? So in this case, we're going to ask something about drive pin punches. How many do we have? So we'll ask a question. We'll see what it comes back with. And then we're going to try to go through and actually see what we get back if it matches. And hopefully it works. I mean, yes. Okay, so what this is doing is it's looking at the data frame itself. Now, I didn't tell it what rows it was in. I didn't tell it if there were more than one row with a drive pin punch in it. What it did, if you click on the here's my analysis, we can actually see that it's going to build a query against the data frame that will do what we asked it in natural language. So it's building out a query. It's looking at the data frame, pulling out description. So that's the header here. If it contains drive pin punch, we don't care if it's capitalized. So we're making a little less ambiguity there, looking at the stock level and then adding up all of those. And if we look in the data frame itself, if you Control F for drive or pin, it'll actually see that we have 2 different rows with drive pin punches. So it was able to understand the context and the structure of the data frame to build a query that would actually pull out, oh, we have 2 rows here. And then I need to sum up this other column that I understand to be the number of those items. Yes, question.
You've got could Excel Copilot do this type of work too? Maybe not in its current format, but when it gets to where you can create kind of a little more data,
Yes.
what you would probably use.
Yes, the short answer is yes. Okay, and now we want to ask something that isn't quite as direct. So this is a little more complex. So we're not only asking about drive pin punches, we're asking about the location, and then how many do they have? Which one has the most, and then how many do they have? So it's writing out all of the thoughts process and what we have here, and it's telling us, here it is. We have 79 drive pin punches at that location, and it was able to identify one location was something that was important. I needed to find the max, and then I wanted to return the location. I didn't want to return anything specific to the word drive pin punch. And so we're able to pull that out from the data frame. Did we have any other example queries or anything? Okay, great. I think we're coming right up on time. So questions, more than happy to stay after and talk also. All right, thank you.